Hi class, in this video we're going to be talking about solving for two-step equations. So the two-step equations that we're going to focus on involve x as the unknown, and in this case they're going to be in this form where we have a number times x plus another number equals to another number, and then a number times x subtract another number which equals to another number, where we're going to try to undo the operations in order to isolate x by itself such that we can solve what x is. Now, for two-step equations, it's a lot harder to guess and check. Now, if you are able to guess that, what number could I multiply by 2 and add 5 to it to get 21? If you're able to guess that that number is 8, then that's very good. However, if the equation gets a lot trickier, then it's much harder to guess and check, as you can see from compared to one-step equations. So we're gonna, in order to solve this, we're gonna go in order of inverse operations. So inverse operations. Recall that BEDMAS is the order of operations that we usually would use. So we solve for brackets first, right? Then we solve for exponents next. Then we solve for division and multiplication, then addition and subtraction. However, what we're going to do now is, in order to solve for an unknown variable for solving equations, we're actually going to use something called reverse BEDMAS. Reverse BEDMAS. And a lot of times when people write reverse BEDMAS, they write it as SAMDEV. So they just write the letters backwards. So SAM Deb would be reverse BEDMAS, which in this case, we would actually try to undo subtraction and addition first, then undo multiplication and division, then we undo anything inside of an exponent, then we undo anything inside of a bracket. So in this case, for example here, I have 2 multiplied by x, and I'm adding 5 to x as well. Since we're going in reverse order of operations, which is SAMDEB, I want to undo my subtraction and or addition first. So since I'm adding 5, I take away 5. But what I do to one side, I do to the other side of the equation. So I take away 5 from both sides. Now 5 minus 5 is 0, so I just have 2x left. And now 21 minus 5 is 16, so I have 2x equals to 16. Now I only have 2 times x left. So now I'm going to undo that multiplication with division. So I'm going to divide 2 from both sides. 2 divided by 2 is just 1, so I have 1x, which is just x, and then 16 divided by 2 is equal to 8. So I have x equals to 8. And we already talked about how to check our work. If I replace x with 8, is it true that 2 times 8 plus 5 equals to 21? Well, 2 times 8 is 16. So is it true that 16 plus 5 equals to 21? Yes, so we know that our answer is correct. So now let's go over some example problems. Here I have 3a plus 4 equals to 16. So recall we want to use reverse BEDMAS, so we're going to use SAMDEB. We're going to apply SAMDEB to our question, which in this case, we undo subtraction, addition first, then undo multiplication and division, then exponents, then brackets. So it looks like I'm multiplying a by 3 and adding 4 to it. So according to SAMDEF, we want to undo the addition first here instead of the multiplication. So I'm going to start off by subtracting 4 from my left side. And if I do that to my left side, I have to do it to the right side of my equal sign as well. Now all I have left, 4 minus 4 is 0, so I just have 3a left. And now 3a equals to 16 minus 4. 16 minus 4 is 12. Okay, now if I were to mark this as a two-step equation, I would give you 1 mark just for getting to this step, and I would mark this out at 2. So now I have to solve for a. So notice I did 1 step to get it to this state. Now I'm going to do another step. Right now 3 is multiplying by a, so I want to undo that and divide by 3. But what I do to one side, I do to the other. By dividing by 3, now I just have 3 divided by 3 is 1, so I just have a left. And my goal is just to get my variable by itself. So I have a left by itself. Now 12 divided by 3 is going to be 4. Hence, a equals to 4 is my final answer. And again, if I were to mark this out at 2 marks, I would give you 1 mark for reaching 3a equals to 12 and the full mark for getting a equals to 4. Because you have to use 2 steps. Notice I did 2 steps here. Take away 4 from both sides. That's 1 step. Then I divided 3 from both sides. That's the second step in order to get my final answer. So now let's go over some more examples. So here I have 8b plus 5 equals to 29. So again, we're going to be using SAMDEB. So I'm going to write out SAMDEB again. And I want to undo subtraction and addition first, then multiplication and division, then exponents, then my brackets for last. So right now, b is getting multiplied by 8 and it's getting added by 5. But according to SAMDEV, I have to use reverse BEDMAS. So I have to undo subtraction and addition first. So in this case, since I'm adding 5, I'm going to undo it by taking away 5. Now, upon taking away 5, all I have left on this left side should be 8b, right? 8b plus 0, which is just 8b. Now, in this case, on the right side, I have 29 minus 5, which is 24. Now, I only have b times 8, so I'm going to undo that. So I'm going to divide both sides by 8. And upon doing so, now I have b on one side by itself, and 24 divided by 8 is going to be 3. So b equals to 3. How do I know? Well, I can check my work, right? So if I wanted to check my work, I can replace b with 3. And let's see if I get 29 from this. So 8 times 3 is 24. And then I have 24 plus 5. Does 24 plus 5 get me 29? Yes. So I know that b equals to 3 is the correct answer. Now, you don't always have to check your work, but sometimes it's a good habit too, in case you're not sure about the work or steps that you took. Now, for my last example here, I got 5d minus 11 equals to 24. In this case, I want to apply SAMDEV and undo the subtraction first. So I'm going to do it by adding 11 to it. So by adding positive 11 to negative 11, I cancel that out. So now all I'm left with on the left side is just 5d. Now on the right side, I have to compute 24 plus 11. That's going to be 35. So now I have 5d equals to 35. Now I want d by itself, so I want to divide both sides by 5. By dividing the left side by 5, since I'm already multiplying by 5, 5 divided by 5 is going to be 1, so I get 1d by itself. And now 35 divided by 5 would be 7. Hence my final answer is d equals to 7.